Alright, write down the definition of conjugates. Conjugates of complex numbers, all you do is change the middle sign. So if I ask you for the conjugate of a plus the square root of b, it would be a minus the square root of b. Now if I just gave you square root b, if you just had one term, and it's not a rational number, for example, square root b, the conjugate would be negative square root b. All you do is change that sign in front of the radical or imaginary number.
So it's just the opposite of the original number?
Not opposite, because opposite you would change both signs. So if I told you to find the opposite of a plus square root of b, it would be negative a minus square root of b. All you do is change that middle one. Now, write down this theorem also. If a plus b is a root of a polynomial, like we were just doing, polynomial function, then its conjugate, change that, that should be then its conjugate, a minus b, is also a root of that polynomial. So the first two examples, like I said, they're pretty simple. I give you the first number, first complex number that's a root. You got to tell me another one that's a root. All right, does everybody have that down? Okay. So let's look at the first example. There you go. See how simple this looks? If I tell you that the roots of a polynomial are 1 in the black, is the roots I give you, 1 plus the square root of 3 and negative square root of 11. You should be able to tell me that 1 minus square root of 3 and positive square root of 11 are also roots. Now be careful what Remy was just asking. Don't take the opposite, just change that middle sign. And the same thing goes, the next theorem, I didn't even write it out, talked about imaginary roots. Same theorem, if you know 3 minus I is a root, then 3 plus I must be a root. If you know 2i is a root, then negative 2i is a root.
Isn't negative 2i the
What do you
opposite
mean?
of 2i?
Yeah, but if you're talking about a binomial, you wouldn't take the opposite of this.
Oh.
Okay.
What do you mean?
It's,
that you know
so in this case, a monomial, the opposite and the conjugate are the same. Yeah.
What do you mean if you know it's a root? It's a root.
A zero. It's where it's crossing the x-axis if you were to graph it. But in this case, it's not going to show that's where it's crossing because they're imaginary or complex. Okay? Alright, so let's go and look at the last example. Try to follow this. Because I will ask you to find the polynomial equation given the roots, which I did here. Look how fun that looks.
What the heck?
Okay, so you have they tell you that you have roots of 3 and 1 plus I. And it says, find a third degree polynomial given that information. So, those top two sentences is what you'll be given. That's it. Okay. Now, somebody's going to make the mistake. Don't be that person. Did I tell you if 3 is a root, that doesn't mean negative 3 is a root, does it? That's you only take the conjugate of imaginary or complex numbers. Okay? If they tell you 1 plus I is a root, what else do you know is a root? 1 minus I. So my 3 roots are 3, or my 3 zeros are 3, 1 plus I, and 1 minus I. I know that's all because it tells me you're finding a third degree polynomial. Okay? Everybody with me so far? Alright, if I know 3 is a 0, you should be able to tell me the factor is x minus 3. That's nothing new. If 3 is a 0, then x minus 3 must be a factor. Okay? If 1 plus I is a 0, then x minus 1 plus I is a factor.
Why is it minus?
It's always minus. Okay, some of y'all like to think of it as doing the opposite. But it's whatever makes the factor equal 0. If I plug 3 in for here, what's 3 minus 3? 0. Okay, it's got to equal 0. If 1 minus I is a 0, then x minus 1 minus I is a factor. Okay, good. So the first thing you need to do is simplify these two sets of parentheses by getting rid of the parentheses inside the parentheses. So I distribute the minus to get x minus 1 minus I. You see that? Distribute the minus here to get x minus 1 plus I. And it doesn't matter which order you multiply in, but the easiest way to get to the answer is to multiply the complex numbers first, or complex factors first. And you'll see why right now. I started out with the black arrows. Take the first number in the first set and multiply it by each of these. So I get x squared minus x plus ix. Does that make sense? Stop me if you have a question. Okay, then I take the second number using the red arrow. Minus 1 goes to each of these numbers. Minus x plus 1 minus I. And then I took the last number, which was minus I, using the blue arrows, and distributed to each of these. You get minus ix plus I and minus I squared. Does that make sense?
Isn't I squared -1?
Yes, that's what I'm going to do in the next step. Okay, I'm going to simplify this. So I get x squared, and then minus 2x, it comes from right here, you get 2 of them. And the ix's cancel each other because one's positive, one's negative. That should always be the case, since you're multiplying conjugates. Also, your i's right here, one's positive, one's negative, they should always cancel out because you're multiplying conjugates. And then plus 1 right here, and this is also a plus 1. Agree? Because I squared is -1.
And it's minus.
Negative 1 is positive 1. 1 plus 1 is 2. So when I simplify all this, I end up with this trinomial. X squared minus 2x plus 2. But you're not finished yet. Because you got to take your other factor that you haven't done yet, which is x minus 3, and multiply it to this result. So I just did the same thing. Take the x, multiply it by each term here. You get x cubed minus 2x squared plus 2x. Take the minus 3 and multiply by each term. You get minus 3x squared plus 6x minus 6. And then you simplify that to x cubed minus 5x squared plus 8x minus 6. Don't forget to set it equal to 0 because these are zeros, so it has to be set equal to 0. All right, question before we move on.
Wait.
No, it's coming back.
That might be a red flag on YouTube.
Okay, question. Everybody got it?
No. Okay.
Remy?
Mm-hmm.
Everybody's good? Okay. All right. That takes care of the last 3 examples. Try those problems.